Present ranges and sensitivity clearly in English, risk English. Welcome! In this micro lesson, you'll learn to communicate uncertainty like a pro. We'll practice how to express numeric ranges clearly, use language that signals uncertainty without sounding vague, and frame sensitivity analysis so your audience understands what truly moves the results. Most importantly, you'll learn to help non-experts grasp risk, what might happen, how likely it is, and why it matters. By the end, you'll be able to present numbers that feel honest, transparent, and actionable, making your insights easier to trust and your recommendations easier to adopt. When you state a range, anchor it with minimum, most likely, and maximum. That tells people the spread and your central expectation. Say whether your bounds are inclusive, including, or exclusive, not including, to avoid misunderstandings. Always give units, percent, dollars, days, so the numbers have context. For example, conversion rate is between 2.5% and 4.0% inclusive, with 3.2% most likely. If you only know extremes, say so. We expect 10 to 14 days, exclusive of weekends. Clarity on bounds and units turns a fuzzy guess into a useful decision input. Pick verbs that reflect uncertainty. Use estimate, project, indicate, suggest, not prove, unless you genuinely have proof. Pair them with probability cues like may, could, likely, unlikely. Avoid absolutes such as will or guarantee unless you're certain. Quantify your uncertainty. Approximately, roughly, around should be followed by numbers, e.g., roughly 3 to 5%. Example: our analysis suggests revenue could increase by roughly 4 to 6% next quarter. The most likely outcome is around 5%. This language is confident yet honest, helping stakeholders calibrate expectations. A clean format helps. Lead with a point estimate, then add the interval. Median loss, $8 million. IQR, $6 million. $11 million. If using confidence or credibility intervals, state the level. Mean impact, $2.1 million. 95% CI, $1.6 million. $2.7 million. Briefly clarify the source. Is it observed data, expert judgment, or a model? Example: projected payback, 14 months, 80% credible interval, 11 to 18, based on historical cohorts and a Monte Carlo model. This structure shows the central value, the uncertainty, and why the audience should trust the numbers. Sensitivity analysis tests how outputs change when inputs move. You vary one input at a time, or a few, to see which drivers matter most. Start with the base case, then compare to alternatives: higher prices, lower churn, slower timelines. When a small change in an input creates a big swing in results, that input is influential. This is practical for prioritizing controls. Focus on the drivers that shift outcomes the most. It also builds credibility by showing where your model is sturdy and where it's fragile. Be explicit about what's held constant. Holding other variables constant, a 1% change in X changes profit by about 0.4%. Rank influence clearly. The outcome is most sensitive to X, less to Y. Note robustness. Results are robust across Z's range. Conclusions don't change. Flag thresholds that change behavior. Above 30%, risk escalates. Below 15%, impact is limited. These phrases make it obvious how to interpret movement, where to focus attention, and when the story meaningfully shifts. If you can't show charts, narrate them. Tornado chart. We ranked drivers by impact. Cost volatility has the widest bar, then demand, then price. Spider plot. Lines show sensitivity slopes. A steeper line means a stronger effect of that input on the outcome. Scenario table. Base case yields $8 million. Best case $12 million. Worst case $5 million. Always state direction and magnitude. A 10% increase in churn reduces margin by about 2 points. A 10% price increase raises margin by 3 points. Words can carry the same insight when chosen precisely. Use repeatable, transparent phrasing. Our estimate ranges from A to B because key assumptions. Under conservative assumptions, the range narrows/widens to values. Findings remain stable except when X exceeds Y, at which point the outcome shifts materially. Uncertainty is driven primarily by driver, with secondary effects from others. You can also add action. To reduce uncertainty, we'll validate driver with a pilot. Reusing these structures creates consistency, helps non-experts follow the logic, and makes your recommendations easier to approve.